Today's topic is arithmetic progression. Let us begin by considering few examples. The first one is 1, 2, 3, 4 and so on. Second example is 100, 70, 40 and so on. Third example is -3, -2, -1, 0 and so on. Fourth example is 3, 3, 3 and so on. Now let us consider the first example. Here the difference between the first and the second term is 1. The difference between second and third term is also 1 and it continues throughout the series. So the difference between every preceding number is 1. Now consider the second example. Here if you observe, the difference between the first and the second number is 30. The difference between second and third number is also 30 and it continues throughout the series. So the constant difference here in this particular series is 30. Now let us consider the third example. Here in this particular series, if you observe, the difference between the first and the second number is +1. The difference between second and third number is also +1 and it continues throughout the series. So the constant difference is +1. Let us consider the last example. In this particular series, the difference between every number is either addition or subtraction of 0. So the constant difference in this series is 0. In all these examples, we see that the succeeding number is obtained by adding a fixed number to the preceding number. So such sequences are called as arithmetic progression. Now let us define what is arithmetic progression. An arithmetic progression is a sequence of numbers where every consecutive number will share a common difference. This particular difference could be a number which is positive, negative or it could be 0 as well. The general form of AP is A plus D, A plus 2D, A plus 3D and so on, where A is the starting number of the sequence and D is the common difference of the particular sequence. Let us consider an example where we develop an arithmetic progression with the starting term 6, that is A is equal to 6 and common difference D is equal to 3. Then the arithmetic progression will be 6, 9, 12, 15 and so on. Now let us consider a similar example where the starting term A is 6 and the common difference D is -3. Then the arithmetic progression will be 6, 3, 0, -3 and so on. You have now learnt what is an arithmetic progression. Let us learn how to find out the nth term of an arithmetic progression. We can calculate the nth term of an arithmetic progression by using the general formula given by an is equal to a plus n minus 1 into d, where an stands for the nth term of the arithmetic progression, a stands for the first term of the arithmetic progression and d is the common difference of the arithmetic progression. We use this formula to find out the nth term of any given arithmetic progression. Now let us learn more about finding the nth term of an arithmetic progression by solving few problems. Let us consider this example where we need to find the 10th term of this particular arithmetic progression. The sequence begins with 2, 7, 12 and so on. Here the first term is 2. The second term is 7. That means the difference between second term and first term is 5. And the difference between third term and second term is also 5. That means the difference is 5. So D is equal to 5. A is equal to 2. Let us fit this in the formula an is equal to a plus n minus 1 into d. So, start substituting. In place of a, we write 2. In place of d, we write 5. So, by solving this equation, we arrive at the nth term of this particular arithmetic progression. So, the final answer is 47 because we had to find the nth term, that is the 10th term. N was equal to 10. So, by using the general equation, we have arrived at the 10th term of this particular arithmetic progression, that is 47. So, now let us move on to another example. Now, let us consider another example. This question is asking us to determine the arithmetic progression where the third term is 5 and the seventh term is 9. Now let us start solving this problem by considering the general equation an is equal to a plus n minus 1 into d. We have a3 is equal to a plus, in place of n we put in 3. So, we have 3 minus 1 into d. So, this will be equal to a plus 2d and this is given as 5. So, write it down here. Next we have a7 which is equal to a plus 7 minus 1 into d, which will be a plus 6d is equal to 9. So, we have two sets of linear equations, that is a plus 2d equal to 5 and a plus 6d equal to 9. We need to solve this simultaneous equations. Then we arrive at the equation d is equal to 1. Now, you can substitute this value of d in any one of these equations. I am substituting it in a plus 2d equal to 5. So, now I get the value of a as 3. So, now we have value of a as 3 and d as 1. So, we can now write the arithmetic progression as in the form of a plus d, a plus 2d, we get 3, 4, 3 plus 2 into 1. That means 3, 4, 5 and so on. So, this is your final answer. Let us move on to another kind of problem where a number is given and we need to determine whether it belongs to a particular arithmetic progression. So, consider this example where the term 301 is given and we are asked to check whether it belongs to a progression which starts with 5, 11, 17, 23 and so on. So, let us start solving this problem. Here the first term is 5. The common difference will be, yes, you are right, it will be 6. So, 11 minus 5 is 6, 17 minus 11 is also 6. So, the common difference is 6. The nth term of this progression we need to assume it as 301. So, an becomes 301. We have the formula an equals to a plus n minus 1 into d. Let us start substituting the known values in this particular equation. So, we have 301 equals to a, in place of a you will be writing 5 plus n minus 1 into 6. So, here n is the unknown. So, let us determine the value of n. We ultimately get n equals to 302 divided by 6, which will be of the value 50.333. But this value is not a whole number. That means it cannot be the value of n. So, we can say that the given term 301 does not belong to this particular arithmetic progression. So, this will be your final answer. Now let us look at another variety of problem by using the same formula. Now consider an arithmetic series where we need to determine the number of terms that are divisible by the number 3. Such a series will begin with 12, 15, 18 and goes on until 99. We need to determine how many numbers are there in this particular series. So come on, let's solve this. So the series begins with 12, 15, 18, so on until 99. That means the starting number A is 12, the common difference is 3 and the nth term, that is an, is 99. So let's determine the value of n using the formula an equals a plus n minus 1 into d. Let's substitute what we already know. In place of an you will be writing 99. So we have the equation 99 equals 12 plus n minus 1 into 3. So what do we get? In place of n you will be getting it as 30. So the number of 2-digit numerals in this particular series will be 30. So you can say that there are 30 2-digit numerals that are divisible by 3. So that will be your answer. Now let us learn how we can apply this formula in real life problems. Consider this beautiful flower bed. Here you see many varieties of flowers arranged in neat pots in different rows. In the first row you have 23 flower pots. In the second there are 21 flower pots. And in the third there are 19 flower pots. And it goes on. Ultimately the last row, as I see, has only 5 flower pots. But can we determine how many such rows are present in this flower bed? Let us solve this by using the formula which we have learnt so far. We have the formula an equal to a plus n minus 1 into d. But what is the given data? A, that is the starting term, is 23. Then what are the consecutive terms? We have 23, 21, 19 and so on until 5. That means the common difference here d will be 21 minus 23, which is minus 2. 19 minus 21 is also minus 2. That means common difference is minus 2. So we have an arithmetic progression here, isn't it? So let's substitute the values in the formula. An equal to a plus n minus 1 into d is the formula you have to remember now. Substitute the values and what do you get? We can solve for n, isn't it? By solving, what do you get the value as? I'll give you a minute, you can note it down. I hope you have written it down. Did you get the same answer as what I got? Phi equal to 23 plus n minus 1 into minus 2. I hope this is the same equation which you have written. So let's continue and solve for n. By equating this for n, you get it as 10. So the number of rows in this flower bed will be 10. So you have this application of the formula where you determine the number of rows in a flower bed. So that is your final answer. So far we have studied how to find the nth term of any arithmetic progression. Now let us learn how to find the sum of n terms of an arithmetic progression. So this topic is about finding the sum of n terms in an arithmetic progression. This can be found out using the formula s is equal to 2a plus n minus 1 into d. This can also be written as Sn is equal to a plus n minus 1 into d, which will be equal to a plus an. Now let us understand about finding the summation of n terms of an arithmetic progression by considering a simple example. Consider this arithmetic progression. Here the sequence starts with 8, 3, minus 2 and so on. We need to find the 22nd term or the sum of up to 22 terms of this particular arithmetic progression. Let us begin by listing out what we know. Here the value of A is 8. The common difference will be 3 minus 8, that will be minus 5. So use this in the summation equation, that is Sn equal to 2a plus n minus 1 into d. Substitute the values to find the final answer. By substituting the values in this particular equation, we get the final answer as Sn equal to minus 979. That means the sum of first 22 numbers of this arithmetic progression is minus 979. This is the final answer. Now moving on to another variety of problems. Here the sum of the first 14 terms in an arithmetic progression is provided and it is of value 1050. It is also provided that the first term of this progression is 10. Let us determine the 20th term of this arithmetic progression. Let us solve by using the same formula of summation. As per the question, the data is given as S14 equals 1050, N equals 14, A equals 10. We need to determine A20. To do that, we first need to find the value of D. So let's begin with what we already know. The value of Sn equal to 2a plus n minus 1 into d. So now let's substitute. We have S14 as 1050. So putting it here, we get 1050 equal to 2 into 10 plus 14 minus 1 into d. Therefore, we get the value of d as 10. Now, substitute this in the value of A20 equal to 10 plus 20 minus 1 into 10, that is 200. Therefore, the 20th term for this arithmetic progression is 200. That's your answer. Now let's have a quick glance at all the important points which we have studied in this chapter of arithmetic progression. First point, an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number d to the preceding term except the first term. The fixed number d is called the common difference. The general form of an AP is given as a, comma, a plus d, comma, a plus 2d and so on. Second point, a given list of numbers, say a1, a2, a3 and so on, is considered to be an AP when the differences between succeeding numbers is constant. That is, a2 minus a1 equal to d, a3 minus a2 equal to d and so on. Third point, in an arithmetic progression, when the first term and the common difference is given as a and d, then the nth term or the general term of the arithmetic progression is given by the formula an equal to a plus n minus 1 into d. Fourth point, the sum of the first n terms of an arithmetic progression is given by Sn equal to 2a plus n minus 1 into d. Last point, if n is the last term of a finite arithmetic progression, say nth term, then the sum of all terms of the arithmetic progression is given by Sn equal to a plus an. So that's all for this chapter. I believe you have understood the concept of arithmetic progression. I hope it was interesting too. For more chapters and lessons, please continue watching Succeed e-learning app.